Lesson 2, other measures of central tendency. In other words, other averages, other ways of summarizing the data in a data set. The first one is called trimmed mean. Is very similar to the mean without the outlier. But when you are taking values out, because we call it trim, to give you a hint what you have to do, you're going to trim from both sides of the data. So you have data, 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 and then you're going to trim one from the low values. That means you're going to trim on the other side one from the high value. So always equal amount of trimming from each side of the data set. Now, because you have to trim low and high, your data set must be ordered from low to high or high to low. It doesn't really matter, but it has to be in order. So one of the biggest things for the trimmed mean is before calculating a trimmed mean, data set must be ordered. So here's a formula. Again, it's type of mean. All of the values make a sum, an addition of them, and then take out equal numbers of outliers on each side. That's why it's a type of mean without outliers. And then again, make sure you count how many data values you have left to divide by that number. So let's have a look at the first example here. Kathy is an electrician. She installs light switches so that they are easy to reach. The values below, and these values are given to you in 2 rows, show the distances in inches between the light switches and the doorways in a home. So 18.3 inches, 36.1 inches, 15.6, and so forth. And we notice how it's not in order. We are asked to calculate the trimmed mean distance, okay? So we have to calculate the mean, and it's telling us which kind of mean, the trimmed kind. To trim on each side, you gotta have this data in order. So let's start with that, with the list of the data in order. I'm gonna list it from the lowest one. So I'm going. Which one is the lowest one? 12.4. So I'm gonna put it right here, 12.4. And when I have to order, so I don't forget any one of them, I always cross the one that I already considered. The next one is, I think, 15.6. The next one is 18.3. The next one is 22.2, but we have 2 of them, so. The next, now we're getting into our 30s, so 34.4. 35.5, 36.1, and last one, 41.7. So now it's in order. I'm going to always double check to see if I have them all by counting them too. So we had 10 in total, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so I'm missing one. 40.2. I left out. There it is. That's gonna go there. 40.2. So now I have them all. And we gotta calculate the trimmed mean distance. So trimmed mean. We're gonna trim 1 from the low end and then 1 from the high end. Okay, can I trim multiples? Is there more than one trimmed mean possible for this situation or other situation? The answer is yes. You can choose to trim 2 values at the bottom and 2 values at the top. And for an actual better example than this one, they have to be clearly lower than the rest of the data and clearly higher, okay? So in that way, your data kind of is more centralized and you're only looking at the data that's more similar to one another. So trimmed mean for our calculation with 1 from each side trimmed off. It's going to be 15.6 plus 18.3 plus 22.2 twice, plus 34.4 plus 35.5 plus 36.1 plus 40.2 divided by 8. And let's see what we get. $28.06, thanks, Braden. 28.0625. So for this one, we have 1 decimal, so pretty good to keep. So 28.1, and we can add the unit as well. That's trimmed mean. So very similar again with the trim without outlier, but you have to trim on each side equal amounts of data. For part B, let's complete the answer. Is there more than one trimmed possible for this situation or other situations? Yes, we could trim. Take out 2 values on each end. So I could take out 12.4 and 15.6. So leave those 2 out, and then 2 from this end. So basically leaving only 6 numbers to calculate the mean. You don't want to trim too much to be left with only a few though. So that's why the population has to be large. Okay? So if you're trimming a little bit, you're still left with a big number of data. The next one for today, it would be weighted mean. So a weighted mean is a particular way of summarizing the data that is not just a list of numbers, but we actually assign to the data a certain importance or weight. For example, usually when we calculate marks in education, so in a class like ours, we assign to each of the categories that you get marks on a certain importance by using percentages. So the weight would be in percentages. If homework is important but not as important because you're still learning, that's why we're going to assign 10%. So it's not too much of your final mark. And then if if partials, so your quizzes are important but not as important still, but a little bit more important than homework, because now you're testing to see if you understood the homework in the lesson, we're going to assign it 20% to show a little bit more importance. And then test or probably the most important ones, because is your prize at the end of the unit, how much you learned. So that's 50%. And then final exam, it wouldn't be for me, that's why you find, and then for probably other teachers as well, final exams are not usually weighted or given too much of an importance because it's cumulative. So of course you're going to have some type of memory loss, right, of all the things that you have learned. So we would be focusing on the main ideas in the course, and sort of, again, to finalize the course nicely, we would give it an importance, but not too much of your final mark. So that's what you're going to learn. Here is how our calculation is done for our class, based on a weighted average, weighted mean. A weighted mean is calculated by multiplying each item in the category by its weight, and then you add all of those multiplications, okay? So for example, the first item here would be your mark in the partials. So I would multiply that by its weight. So if you have an average of partials mark of 78%, so 78% times the weight of a final calculation, which is 20%, so times 20, like that. The second item would be test. So if you average on tests about, let's say you get 80% in each test, the 80 times its weight, which is 50%, and so forth. And then at the end, it's out of 100 for us. That's a total weight in percentage, but sometimes it's not out of 100, it's whatever points were assigned for that particular calculation. In example 2, we do just that. We look at a mark calculation. The table shows Tristan's physics marks. And then we would see here that he gets marked for homework, and then his mark in homework is 90. Quizzes, his mark in quizzes is 62. Projects, his mark in projects is 68, and exams, total exams 75. And then here are the weights. Okay, 10% is the weight or the importance of the homework, 25 for the quizzes, 15 for projects, and exam count for 50%. Now, all of this is usually, when it's percentages, it's out of 100, right? Because that's the total maximum amount of percentages. But always make sure that you calculate, because not all of the weights are percentages. So 10 plus 25, 35. And then we have 50 here, and then 50 more, that's 100%, okay? And it should be. Now let's calculate Tristan's final course mark. Because we have weights, we have to calculate the weighted mean. Homework, so we have the item homework, he had 90%, so times 10. Plus the second item quizzes, he had 62 times the weight, which is 25. Third project, he got 68 in them, so times 15. And then exam, he got 75%, so 75 times 50. And then divide by the total weight, which is 100. So all of these are the weights. Total weight is 100%. Also, you have a top calculation that has multiple items. Make sure you do equal here, get the final amount there, and then divide by 100. If you got the answer, you can type it up. Thanks, Darian. 72.20, and it's going to be percent for this mark because we had percentages as the items, right? So if the items are percentages here, right, our final answer would be percentages. If the items are points, the final answer would be points. And we have an example like that as well. Everybody good? Any questions? Okay, this one, example number 3, is with points. Samantha assesses job applicants, so she's in the hiring committee. Emily and Bailey interviewed for a position. So Samantha interviewed them for a position, and each of them got scores from 1 to 5 for these categories. Okay, score 5 being the highest, so the better score. And then the question is, who should get the job? If you want to be as objective as possible when you're hiring someone, you would follow something like this. Okay, you would say that for this job in particular, we need a certain type of education, so the more education somebody has, the more training, the better score they would get, right? So it's 25. We're going to assign a weight of 25 out of, let's see how many they got here. The total weight is 45, 85, so 100, right? So out of 100 total weight, so you can think this being a percentage too, they assign 25% for education. Now, notice how communication is the highest one. So maybe this is a job in service, right? When you have to work in the customer service position, you have to have good communication skills so you can communicate with the clients and get what they need and find out what their wishes and wants are and how to help them fulfill those wishes and wants, right? So communication, very important. They assigned 40 for that. So the better communicator you are, the more points you get, right? So there's ways to figure it out if you're a good communicator by asking questions and looking at the applicant's responses. And then experience, 20%, so not so much. You can probably build the experience on the job. And leadership, probably not a managerial position, so leadership skills not the most important ones, right? So we do that, we assign some weight to what's important to the job, and then we design a questionnaire with questions and answers, and we can give the applicants a score. So here are average scores for each of these categories. So in education 5, experience 4, communication 3, leadership 2, and then Bailey scores, right? And then we don't really know which one should get the job, but we can do a weighted mean calculation and get an objective number that can help us decide, especially when you as being in HR, like in a human resource department, and you make the hiring, maybe you liked both Avery and Bailey's personalities and you just can't decide which one should get the job, right? And then a number like this can help you. So we're gonna do Avery first. Weighted mean. And again, we're gonna have to do the score times the weight. So 5 times 25, and then 4 times 20, plus 3 times 40, plus 2 times 15, and then divide by the total weight, which is 100. We're gonna get a score for Avery, and you're gonna type it up if you get it. And then we're gonna get a score for Bailey by calculating the weighted mean. So 3 times 25 plus 5 times 20 plus 4 times 40 plus 2 times 15. So I got 3.55 for Avery and 3.65 for Bailey. Confirmed? Give me a thumbs up.
That's what I got.
That's what Harrison got. Gonna make an assumption here that everybody else is good with these two numbers. So now our final answer to answer the question, who should get the job? We will say Bailey should get the job. Based on the weighted mean score. Okay, 5 minutes on these, and then we move on to the next part. So 8:15. We'll work on median at 8:15. Your turn. So the next calculation for a measure of central tendency, it's called a median, is a way of having or finding the halfway between all of your data values. So it's the middle value in a set. But again, to find the halfway of the data, you want to make sure your data is ordered before you start finding that halfway. Sometimes I'm going to just give you a couple of examples here. So I'm going to use circles again. So if you have 4 pieces of data, okay, so an even number of data pieces, halfway is in between. So what you're going to have to do is average the two values beside that halfway. But if you have an odd number of data pieces, like let's put 5 in the situation, the halfway would be a specific number, and that's it. That's the median, okay? So if it's even, you got to calculate the average of the 2 middle values, and if it's odd number of data pieces, you just have to find the one that's right there in the middle. So that's what example 4 and 5 do. but this time I'm going to use numbers, and it's not ordered, so we want to make sure first it's ordered, and then we look for the middle value. Find the median of the following values. So we have 65, 55, 89. So let's find the lowest one and start with step number 1. Here you can see that in some of your pages of your notes, I give you a method, a step-by-step method to find these. So in the first step, we want to make sure it's in order. So start with the lowest one. I think it's 14. I'm going to cross it off. And then do I have anything in the 20s? No. 30s? Yes. 35. And I think that's it. How about the 40s? 45. In the 50s, we have a few. So we have 55 twice. And then we have 56 twice. We're done with the 50s. We're going to the 60s, 65. Done. Then 70s, there's none. And then we have 87, 89, 92. How many in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is an odd number of numbers. So if you're looking for the middle, let's cut 2 from here, 2 from there, 2 from here, 2 from there, 1 from here, 1 from there. The middle is number 56. So the middle value called the median is 56. Now the other one is still the same values. I took out one of them to make it now an even number. So let's order them again. So 14. I think it's the same numbers, 35, right? I'm pretty sure 45. Where are you? 45, 55, 56, twice. 65, 87. Oops, did I miss one? 55 twice, right? That's one. 87 and 89. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's even. So if you're cutting from the left and the right 3, and then you have 1 here and 1 there, you're left with these 2 values because halfway is in between them. So to calculate the median, now you have to do the mean of the 2 values. So 55 plus 56 divided by 2. So 55.5, right? So median halfway in a data set. If it's an odd number of data pieces, the median is right there in the middle. You just take it from the middle. And if it's even, you have to calculate the average of the ones that sit in the middle, because there's 2 of them in the middle. Make sure your data is ordered before you start searching for the median. Mode is going to be our last type of summarizing the data. The mode of a set of data is the number, if it's number data set, or characteristic like color, that occurs most often. So if I have a data set that doesn't have any mode, that means no number or color characteristics will repeat more than the other one. So let's list numbers because it's easy to understand. So if I list numbers from 1 to 5, 1, 2, 3, 4, 5, they each appear once. So this set doesn't have a mode. But if I have a data set with one mode, one of the data set appears more often. So 1, 2, let's do 3, 3, 3, 4, 5. In this situation, I have one mode, the number 3. So mode would be number 3 because it appears most often. And we can have more than one mode if multiple pieces of data are as frequent as the other ones. So if I have 1 and then 2, 2, and then 3, 3, and then 4, 5. So 1, 4, and 5 appear once, but number 2 appears twice, number 3 appears twice. So these ones are more frequent, more often. So we have 2 modes, or number 2 and number 3, because they appear more often equally between each other. Example 6. In a crash test, 11 cars were tested to determine what impact speed was required to obtain minimal bumper damage. Find the mode of the speeds given in miles per hour, that's the unit, below. So we have a list of speeds. We want to see if any one happens more than other. Now, when you have a big data set, not just 11, but it's even if you say 50, it might be easy to keep track of how many times something happens by doing a tally, right? So tally means you do 1, 2, 3, 4 lines vertical, and then with the fifth one, you cross it over, and that's a group of 5, and it's easy at the end to count them. Now for these ones, there are not that many, you don't need tallying, but yeah, for other things you might. So I would usually do with these ones, I would start with the first number in the list, the first speed, 24 miles per hour. And then I would go down the line and see how many times it appears. So 1, 2, 3, right? So 1, 2, 3. And then we'll do the next one in the list, 15. 1. So only once. And then the 18 is the one on the list, and I go 1, 2, 3, also 3 times. And then number 20 in the list, once. Number 22, once. And number 26, 1, 2. So you're looking at the numbers, the miles per hour speeds with the highest frequency. So this one occurs 3 times, this one occurs 3 times. So that's the highest from all of the counts. So our modes are 18 and 24. Okay, so example 7. River surveyed people to find out how many online news sites they use. So basically, River is trying to find out if you are looking for news and then you want to make sure that you're reading the correct news, are you double checking other sites, right? Are you just going always to the same source, or are you actually spending some time and you use multiple sources for your news, right? So what we are searching here, just like here, we were looking for modes for the speeds, and they are still numbers like 24 miles per hour, 18. This data is organized in a chart. So these are the corresponding values for the speeds, okay? So I wanna see, is no news sites the most popular one based on how many people are doing that? Is one site most popular one based on how many people are doing that, and so forth, okay? So in this situation, the tally is in here. It's the number of people that do this, okay? Visit these sites regularly. So 6, it would be like that, right? 6 people don't visit any sites, only any online news sites. And then for one news site, we have 15. So your tally would be like that if you would be actually doing the survey and counting how many people actually said yes to number 1. And so forth, right? So now I don't have to keep doing this. I just want to really explain to you which one is the value we are trying to find the mode for, and which ones are the counts or the frequencies, the tallies for those categories. So now which one is the most popular number of visits per week? So we have the one that has the most tally, which is 38, right? Okay, so now the mode would be 3. 3 sites per week. 3 online news sites per week. And these ones, yeah, they always get to be a bit more confusing than the other types, the data that's in the list. So try to figure out which one is the count and which one is what you're trying to survey for. So there's going to be 1, your turn, 2.2 here. And then at the end, we're going to do making a decision, couple of pages, because you will need to know again which type of measure of central tendency you should use in various situations, because not all of them fit all the data, right? So I will teach you when to use trend mean, when to use mode, when to use median, right? Mode is really good. I want to add this to your notes here. So it's in the definition, but just to be clear that if I have a list of colors or flavors of ice cream, okay, if I want to figure out which one is the most popular one, there's no other way of summarizing those favorable colors or favorable flavors of ice cream, but with the mode, right? Keeping a tally which one is most popular, right? So mode would be a good option for qualitative data. Characteristics like colors, flavors, shoe sizes. I guess this is a number, but popularity would be like, of the shoe size would be part of a mode. If you want to find out which one is most popular, you can do mode. Okay, so your turn 2.2, and this one 5 minutes, 8:35. So for trimmed mean, we're going to be using it when, just like with the mean, data has to be similar to one another, so very much alike. But then you will have outliers on both on the high and the low end of your list once your list is in order, right? So you have low and high outliers on each end, and then you're going to trim it, and then it's going to look better because you have the leftover data that's similar to one another. And then we're going to use weighted mean when data has an importance assigned to it, a weight assigned to it, and that means we have to use the calculation that's called weighted mean. This one probably it's the easiest one to figure out because you see the weights right there in the data. We're going to use the median. This probably is, from my experience with my students, the hardest one to spot when the data values are spread. Okay, what does it mean to be spread? So they're very different to one another. You can think about them as being in an increasing trend or a decreasing trend. So something like this, like 7, 8, 9, 10, 13, 20, 22, 25, right? So it kind of follows an increasing trend. No, 4 values are very similar to one another or like a group of them. So this is called a spread data, okay? So either like sort of increasing or decreasing depending on the order you're putting them. In this situation, the median is really good. Now there's also other goals when you're trying to summarize your data. So for me as your teacher, sometimes instead of doing what's the class average of for example, your test marks for test number 1, if I have a group or a handful of students that are doing really well, and the leftover group of students are doing sort of kind of good, like in the middle, in the 60s, and then maybe a couple of them not doing so good. If I do the average of those data, it's not going to fall, or it's not going to give me a good understanding of how the test went. But if I do the median, if I find the halfway mark, I'll know that half of my students scored less and half of my students scored more if I find the median. So if my median value is in high 70s, that's a good mark because half of my students did more than 75% and half of them did less. It can be closer to 75, but it can also be further down, right? And for that, I can just look at the values. So depending on the needs, also you can choose which one you can use, but here we're just doing basic statistics. That's for further on in your statistical courses. The mode, we're going to use the mode if there is data that repeats, right? So it's more frequent than other. And we are interested in frequencies, popularities for, I think I already mentioned this example. So if you want to figure out which shoe size is the most sold in your store, if you're a store owner, then you're going to do a mode, keep track of how many you're selling of that shoe size, and then you're going to order more because that's what you should be doing to figure out to have enough stock, right? Same with a t-shirt if you're selling clothing. And obviously for non-numerical data, like we added on into our notes, favorite ice cream flavor, if you want to figure that one out, you don't have any other one that will help you figure out which one is the favorite flavor. So this would be what we call a non-numerical data, right? The ice cream flavor, colors, and all that, not a number. Here's an example. Suzanne works at a cat rescue shelter. When the cats come into the shelter, she is responsible for measuring the cats. She found the following measurements in centimeters. So 25 centimeters, 26, 15, 16, 28, and so forth, okay? The question is, which measure of central tendency do you think is the best for this data? Explain and then calculate it or state it, because sometimes you don't need to calculate it like the mode, you just have to find it and state it. Now, because a lot of the summaries that we have used, the measures of central tendencies, require the data to be in order. Before you make a decision, put your data in order, and then you can decide in the best way possible. So we have the lowest length is 15. And then 16, I think they're pretty much a lot of them in order. 17, 18. Is there a 20? I don't see a 20. 22. Nope. 23. 24. Nope. 25. 26. 27. 28. 1, 2 of them. 29. 32. 39. Okay, so now, is my data similar to one another? If you look at, nope. So that means not mean, right? Is my data similar to one another, but only one is different? No, because obviously similar has to be part of it. So I can choose mean or mean without outlier or trimmed mean. Because for all of these ones, one of the requirements is to have the data to be similar. Okay, so not mean without an outlier, not trimmed mean. Okay, now
I want to know again about this similarity. How the similarity take place?
are the numbers close to one another?
Just like how 28 close to 28, you mean?
But all of them, right? Not any two numbers, all of them as a group.
Oh, okay. So like if you got 15, then you got another 15 again, something like that, 16,
Yeah,
another 16. If they
yeah,
all
exactly.
similar both together,
Yeah, like that. So something like that. Or if this list would be like this, 15, 16, 17, 15, 16, 17, 17, 16 again. So somewhere close to one another. That's a similar data, right?
Okay.
That makes sense.
Okay.
They're very close to one another around that value of 16, just oscillating a little bit high up, high down, up, down. This would be similar. But if you have like a range of values, so you almost look like it's increasing right all the way to the high 40s, it starts at the 15, right? With the 15 and 39 not being the outliers, right? So you can say these are the only two different ones, and in the middle they're similar. No, right? Not that case. This is what we call a spread data.
Okay, I got you. Okay. Thank
Yeah,
you.
okay, spread. Yes. So when you have spread data, we said the best way to summarize it would be the median, right? Now, if you have a spread data and then you have one value like 28 here that appears multiple times, let's say 4 times, you can also choose mode. So for one data set, you may have different options, okay? And it's up to you to explain why you chose the median or other options, right? So some questions can have multiple answers and neither of them is better than the other as long as you explain why you decided that and your explanation is correct. So median, let's find it. How many cats were they measured? This is she's saying no, we have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 cats, so that means we have two numbers in the middle. 5, these ones average of that, so 26 plus 27 divided by 2 gives us 26.5 centimeters. That's the median. Claudine did a survey to find out about people's favorite colors. So even just reading this first sentence, a survey to find out something that's favorite, right? The popularity of a color. That's going to be ... right? I know what it is already. She got the following results. For red, there's 13 people liking that color. Blue, there's 15, 19 people, and so forth, right? Which measure of central tendency do you think is the best for this data? Explain and then calculated / state. I'm going to let you answer this one. So it's this one because so write it in chat. Do you think it's the mean, or like just mention which one? Do you think it's the median, weighted mean, mode? Median, I don't know if I said median. Which one do you think it is? No one? I can't believe that. I know you know the answer.
I want to try.
Yeah, go ahead. You don't have to ask permission. Just go for it.
Yeah, I can choose like the weighted mean because
Yeah.
it's choosing about the importance of the favorite color.
Sure. And how will you calculate it if you don't have the number? Because the weighted mean is it's a calculation, right? So you have here a tally, right? So you have here 13, right? The number 13 for the color red, but then you would need to multiply. How are you going to multiply red times 13? Right? Because the weighted mean calculation requires you to plug something in the calculator. So can we choose weighted mean after we had this discussion?
All right, I see.
Can you do that?
No, I see now. I see that.
You see now, right? So it's not it,
Yeah.
right? Not
It's
it. I can't do it.
Yeah.
So not weighted mean. Okay, then I see trimmed mean. Okay, is it trimmed mean? Well, again, is it a numerical data that you can order? Can I write red, blue, yellow in an increasing or decreasing order to be able to trim it? Who's going to decide which one is first and second, right? Because with numbers, which you're going to need trimmed mean for numbers, then it's really easy to order the data, right? So not trimmed mean because I can't order the data. So not trimmed, not the weighted mean. Which one allows us to figure out the popularity of colors? Which one allows us to do a measure of central tendency for data that's not a number, that's non-numerical? The answer is on the previous page.
I think it's the mode.
I think you're right, Amadou. It is the mode, right?
Yeah.
The mode looks for popularity, right? So mode. And now why? Because one of the reason is data is non-numerical, and you don't have any other option for that, but we are looking for popularity, right? A favorite color, favorite ice cream flavor, a popular shoe size, t-shirt size, and so forth. We are looking for popularity. And popularity is going to translate into these counts, okay? How many people love red? How many people love blue? And so forth. Now, which one is it? Because yes, first we have to choose which one is the best and explain, but we also have to state it now. The mode for the colors is what color? Which one, since we're in the voting election season, which color got the most votes? Blue, no pun intended. Because blue counts are 19. Oh, actually not 19, but I think there's still this one is missing a line, so 4 there. But I think just by it's a typo there. So 10, that would be 18, but I think, yeah, I still think it's the highest number. Yes. Good job, everyone. This is it. So next class, we just have one more lesson to do, percentile rank. If you look at your first page here, we've done types of mean, we've done median mode. All we have to tackle is percentile rank. And these two are related, the median with percentile rank. It's kind of a similar way of looking at halfway to the data set.